First of all, a little bit about me. My name is Chris Whealy. For reasons I cannot explain, my last name is pronounced Whealy, not Wheely, Wally, Whirly, or any other variation you could think of. I was born with it, so hey. I'm going to talk about joining the world of Rust, or attempting to join the world of Rust to the world of SAP. Has anyone here used an SAP system? Okay. Has anyone here never heard of an SAP system? Okay. Has anyone here never heard of an SAP system but doesn't want to admit it? Because there's always a few. Right. SAP is, I think, the third largest software company in the world, behind Microsoft and Computer Associates. And it's the biggest software company you've probably never heard of. But it is widely used by all your large multinational companies. It is, for some companies, it is the engine that drives their entire business. So for instance, if you buy anything from the Apple Store, your invoice comes from an SAP system. Microsoft uses SAP for all its internal accounting. Big multinational companies like Unilever, GlaxoSmithKline, Nestle, these are all big SAP users, but it's the type of software that you never really see up front. So, I spent 24 years working at SAP, and in that time, I wasn't actually a Rust user. It's only after I left SAP in 2019 that I started to use Rust. And then, after a while, I realized, based on my previous experience with SAP, I thought I could write an interface into an SAP system in Rust. And that, I think, would work very well. However, these are two worlds, two communities that never normally communicate with each other. Now, I know that there is a bit of internal development in Rust going on within SAP, because I have still got a few contacts there, but let's just say it's not a mainstream language there yet. So this is my attempt to bring these two worlds at least closer together. Maybe not join them up, but at least make each aware of the other. So what we're going to look at is using Rust software to interact with an SAP system using OData version 2. Now, I need to be quite specific about the version of OData because there is a version 4, but that's out of scope here. So, has anyone heard of OData? One lone person at the back. Okay. OData was originally developed by Microsoft as a technique for exposing the schema of a SQL Server database to a web interface. That's the basic concept. It's, as it says up there, it's been loosely described as SQL for the web. And when we start to look at how these queries, how a web query works, you'll see there are, at least conceptually, similarities to making an SQL select statement. As I've said, this presentation focuses exclusively on the version 2 implementation of OData. That is stable, and it has been for over a decade. When I was at SAP, I developed all the training material for the original version of OData, that's the version 2. So that's why I have such deep knowledge of OData, because I wrote all the training material when I was at SAP. We're not going to talk about version 4 because that's actually a very different interface. So, oh yeah, by the way, OData is also an OASIS open standard, so it's fully standardized, and SAP and Microsoft are jointly on the committee for that standard. So, if we have this basic schema in our database, this is Typical of a business system, you've got your business partners. They will raise sales orders. Each sales order has one or more sales order items, and a sales order item relates to a product. It's a fairly simple data model. The idea with OData is that you could issue a URL which ends in business partners, and this basically acts as a select star from business partners in the database. So your web request literally translates to an SQL statement. That's the original idea. And as you can see, if I were to add a parameter to that argument, that would be a select single. Or we can now traverse this relationship between business partner and sales order. So this would be a foreign key relationship. And I can say, for business partner that, show me all the sales orders. And as you can see, this web interface allows you to navigate through the underlying data model. So for instance, I could say, show me the sales order items for a particular sales order. It's all pretty standard stuff. I can put a bit more detail in there. Show me the sales order items for a specific item on a specific sales order. You get the idea. So that's the concept. I hope that all makes this pretty straightforward stuff. Now, this was how Microsoft originally envisaged this working. You would have your schema in your database, and you would directly expose that through the OData interface to the web. SAP, however, if you ever look at the data model or the schema of data in an SAP system, you'll want to run away. It is extremely complex and also very abstract. So there's no way you could directly expose the schema of an underlying SAP database directly to the web, because it wouldn't make any sense to the end users. So in SAP's implementation of OData, there is, shall we say, a middleware layer of software that takes your web request, translates it into something that makes sense in the underlying database, and then gives you your data back. But that's internal to the SAP system, so we're not going to look at that. So let me give you a bit of history of OData, because when we come to look at how I've implemented the Rust functionality, you need to know that OData is based on Atom. Anyone remember the Atom syndication and Atom publishing protocols? All right, anyone old enough to remember those? Yeah? So the Atom syndication protocol was a read-only XML-based interface where publishing companies that syndicated material from a variety of authors could then make that information available through a web or a web-based interface. What OData does is it extends these protocols and gives you SAP annotations that sit on top of the Atom protocol. So when we come to look at the data that comes out of, or when you invoke an OData request, the data you get back is going to be a combination of Atom XML plus SAP add-ons. So these SAP annotations include things like a unit of measure for a quantity field, or a text description for a particular field. So these Atom formats are XML-based. They're typically consumed by whoever is wanting to access to that syndicated content. Now, here's a bit of terminology that you will need to remember. When you make a request to an Atom server, you get back this thing called a feed. We're going to see that name popping up out of OData. And a feed consists of 0 or more entries. I say 0 or more because if you do a select SQL statement, it's possible that you might get nothing back. So that's why the feed could contain 0 entries. The Atom publishing format was added because Atom syndication is read-only. So Atom publishing allows you to modify the underlying protocol. The problem here, and this is a pretty big problem, is that if you want to consume an Atom feed, you need to know upfront what the structure of the data will be that you are going to receive. There's no way you can discover that at runtime. You just have to know. Now, this is a problem because this lack of functionality is what means that Atom protocol is not fully RESTful. REST, I know through popular usage, REST has been talked about as if it's a protocol. It's not. REST is just a set of design constraints. There's 6 of them. And one of these constraints is that the data must be self-describing. So this is where Atom is not fully RESTful. So SAP said, well, okay, that's not a showstopper. We can work with this. What we'll do is that we will extend Atom by providing a metadata description of the content. And this is basically the foundation of what allows my Rust software to actually work. If it weren't for this metadata being exposed, I wouldn't have been able to write any software. So, what do you get in this metadata? Well, you get definitions of simple types, strings, numbers, dates, all sorts of things. But you also get these things called complex types. So remember that an SAP system is dealing with business data. So the focus is not so much on the technology, but the focus is always on the business process being implemented. One of the things that is actually quite complicated is addresses. If you've ever had to format, has anyone had to format an address for different countries in Europe? 1, 2. It's a pain in the neck because in some countries you put the house number first, then the street name. But in Germany you do it the other way around. And in some countries you put the zip code or the postal code or whatever you call it in one place. So every country in Europe has its own format for an address. So something as simple as an address is actually pretty complicated when you have to account for the different standards that apply in different countries. So out of an OData system, you can get this complex type, and the simplest example is of an address. And that will handle all the known address formats. And the address formats in Japan are even more strange, at least to my way of thinking. Associations between entries. This corresponds to foreign key relationships. This is all encoded in the metadata. Navigation paths between entries. And this is actually a very useful feature, custom behavior beyond standard CRUD operations. So CRUD is your create, read, update, delete. Those are the basic operations that you perform through a RESTful interface. Those correspond in HTTP to your get, your post, your update, your put. Those HTTP methods are then the implementation of the CRUD concept. But again, as I said, SAP is focused not on the technology, but on the business process being implemented. So let's say I've got a sales order, and the customer says, oh, I want to cancel that. What CRUD operation is that? Well, you could say, okay, it's an update. Well, yes, you're changing an existing order, but wouldn't it be nice if we could have a specific operation that says cancel? Or this is now where, as I go, I'm going to keep emphasizing this. The focus here is on implementation of a business process, not on the underlying technology. So these custom behaviors in OData are known as function imports. It's a rather non-intuitive name, but it means I can create my own operation like cancel sales order. And then the person consuming that operation knows exactly what it's going to do because I've given it a meaningful name. It's not just a generic update. Now, in the software that I've written, I don't actually handle function imports, simply because I haven't got round to implementing them, but they are there should you need them. So, how do we get access to one of these servers? Well, either your employer has got one. Honestly, it's very unlikely that you're going to have an SAP system running on your laptop, unless you've got a very powerful laptop. It can be done, but your laptop can't do much else if it's running the SAP system. So I don't know if anyone's particularly interested in this, but there is this, on the developers.sap.com website, there is this blog that shows you how to sign up for a demo account. And because I no longer work for SAP, I don't have access to any back-end SAP systems other than this demo one. So that's the system that we're going to use for this demonstration. But there is this server, SAP ES5 sapdevcenter.com. That is the address of this demo OData server that we're going to be working with. So, if you want to invoke an OData service, you need to know this thing called its base URL. Now here's where we run up against an age-old situation that has always existed as long as I can remember in SAP systems. And that is, how do I discover what services are available on an OData server? Sorry, I'm using the SAP terminology here, NetWeaver Gateway. NetWeaver is a suite of products that came out nearly 20 years ago. That is a range of SAP servers that are collectively called NetWeaver, and the type of server that issues OData services is called a gateway server. So that's the official SAP terminology. So if I've got this address like SAP ES5 sapdevcenter.com, well, that's nice. How on earth do I figure out which OData services are exposed by that server? Well, you just have to know. Now, fortunately, there is a service called Catalog Service, and this is an OData service that exposes the other OData services. So, as long as you know how to get to Catalog Service, then the door opens and you can get access to all the other services. So, now knowing that there is this OData service called Catalog Service, how do I construct the URL? Well, here's another thing you just have to know. All OData URLs follow this pattern of the server name, then it's SAP OPU OData, where, for reasons that I'm not entirely clear on, where's my mouse pointer? OPU stands for Occasional Platform User. Someone in Waldorf thought that was a good idea. Okay, let's just go with it. Then you have the namespace, and then you have the service name. So if we know that pattern, and we know the namespace and the service name, we can construct the URL. So you see what I'm doing here? We're sort of building things up step by step to work out how to interact with this system. So here we have the actual OData URL, and you can issue this either directly from your browser or you could put it into Postman, doesn't particularly matter. What is important though, if we remember from the previous slide, you actually have to sign up for an account on this service. These are authenticated requests. So you must have a user ID and password on the system before you can access this. So if I were to issue that URL on its own, I would get back this large lump of XML. I'll just show you that. Yeah, there you go. Great. XML, as everyone knows, is quite verbose. So, as a way around that, what we can do is I can put a query string, and I can say $format equals JSON, and if I just, I can't see the screen. This is awkward. Hang on. Where's my mouse? Oh, okay, I can't. You'll just have to believe me. Because I can't actually see the screen from there. But this will then give you a much more compact JSON response, and JSON is much easier to read. Here we go. There's one with a link already done. So we're going to be using this. There's the JSON response. This is an OData service called GW Sample Basic, and it's just your off-the-shelf demo OData service that has a data model very similar to the one we started with business partners, sales orders, sales order items, and products. It's a pretty basic data model. This response that you're seeing here is something called the service document. This is the top-level starting point, if you like. This is telling you what feeds are available from this OData service. So remember from our Atom terminology, a feed is a set of things that you can gain access to. So at the top there it says business partner set, product set, sales order set. If you remember that OData is designed to expose the underlying schema of the database, broadly speaking, you can think of that business partner set as a table in your relational database. And when I query the contents of, say, product set, that's like saying select star from product set, and you'll get back a set of responses. So there's the that XML, JSON information. Now, if I want to request the contents of an entity set, notice the format of the URL. I've got, where's my mouse pointer? Oh, I can't see the mouse pointer. Okay. So there's the OData service name, and now I simply append the name of the OData entity set there, and also the query string $format equals JSON. And that is now going to give me, this is an extract, but there is your actual business data. This is the stuff you're interested in when you're writing a business application. So, okay, that's nice, but now we come to the whole point of this presentation. How on earth do I consume that data from Rust? So this is why this presentation exists and why I wrote the software. Well, if I want to consume that data, I could manually type in a Rust struct that represents that format, but I would have to do that for every entity set in the OData service, and if that ever changed, I'd have to manually correct it, and it's going to be an error-prone and fairly tedious process. So let's not do that. The point here is that because OData services are self-describing, I can add the $metadata command to the end of a URL, and I'm going to get back an XML description of the service itself. And that's what my software actually consumes and translates all that XML into Rust source code. One point here is that this metadata is not available in JSON format for the simple reason that, do you remember at the beginning we said that OData is an OASIS service? It's an open, standardized service. Nobody can agree for how metadata should be communicated through JSON. Nobody can agree on that. So the XML format has to be used. It's a bit more verbose, but it's actually in this case, it's a very rich format. So if I, let me see if I can, sorry, I don't know where I don't know where my mouse pointer is. Okay, I'll have to base it on the slides. If I just take the base URL of an OData service and simply append $metadata to the end of it, I'm going to get back some content that looks similar to this. This is an extract, this is not the whole document, but what you can see is that I have this XML element called an entity type, and there's the name of the particular entity type. And within that element, I have a set of property elements, each one representing one of the columns in the table. You're going to see this abbreviation EDM a lot. That's not electronic dance music. I know some of you might like it to be, but that means entity data model. So this is an open standard. So you can go to the entity data model standard itself and you can find out exactly what a string actually means. There's another detail here that doesn't translate to Rust. And notice that on these strings we have a max length field. In SAP systems, you can have a string that is variable length up to a point. So the string can have a maximum length of, say, 40 characters, and it can be variable up to 40. That doesn't translate to Rust. So there are certain details that just I haven't yet thought of a way of doing this. I suppose you could create a fixed length string data type in Rust. I haven't actually spent the time to do that, but yes, if this is causing an issue, then yes, we could do that. But the point here is that the software I've written consumes that XML and generates Rust source code. So the two Rust crates that I have written are called parse SAP OData and parse SAP atom feed. That is the download count as of yesterday, which I think is fairly reasonable. Unfortunately, does anyone know how to get Crates.io to tell you who is downloading your software? Because I haven't figured it out. It gives me just that number, but I honestly do not know who's downloading this software, but someone is, and they're doing it quite regularly. So thank you, whoever you are, but I just don't know who you are. So the point here is that we need a pair of crates. The first one, this is the crate that runs as a build script, and it transforms the OData XML, this metadata, transforms that into two Rust modules. One module is for the service document. So do you remember he said, if you issue the base URL of an OData service, you get back this list of entity sets. That's like your starting point. This is like your menu. Here's the things I can access. That's called the service document. The other Rust module is a Rust representation of the metadata itself. So I'm basically taking the XML metadata and transforming it into an equivalent representation in Rust. Because when you're interacting with an OData service, you need, if you're really going to do things properly, you're going to need to say, well, I've just got back a string from the SAP system, but that string has a text description. The metadata module is going to hold the text description of the value you've just retrieved. The other crate, this is a crate that uses these generated modules at runtime. So this is the crate that your business application actually uses at runtime, and this is the one that actually interacts with the OData service, extracts the information, and presents it to your Rust application through the two generated modules that this crate created. So that's how these crates function. Largely because of time, I'm not going to actually go into the internal workings of the crate. I've documented it as quite thoroughly. But basically, Parse SAP OData sits on top of SERDI. And SERDI does all its clever magic and transforms the XML into Rust. I had to play a few games like transforming a EDM.decimal field into a Rust decimal field. That took a bit of playing around. I had to write a custom deserializer in Rust to actually make that work. But broadly speaking, Parse SAP OData sits on top of SERDI. And I think anyone who's been a Rust developer for any length of time will be reasonably familiar with SERDI. Is that a safe assumption? Yeah, so I don't really need to go through that. But let me just give you a quick overview of how you would go about building a project. You do your cargo new, create a new project, and the first thing you're going to need to do is to create an OData folder in the top level of your directory. Into that folder, you're going to place a copy of the metadata from your OData service. So you've got to know your OData service base URL. You put $metadata on the end, and you get back this large lump of XML. You need to copy and paste that into that file. Now, some people have said to me, well, why don't you just get the build script to go and access the back-end SAP system and suck out the metadata at runtime? Because that's an anti-pattern. If you look at the principles on the Rust-Lang website about how you build a build script, they specifically warn against build scripts looking outside their local service or their local file system. The reason is, if I were to make a network request during a build script to try and access that OData service, what would happen to your build pipeline if that server was down? Kaboom. It would stop working for reasons that are entirely outside of your control. So the principle is that all Rust build scripts should be entirely self-contained, which is why we put a copy of the XML into that local file in your project. It also makes life a lot simpler because, remember, the request to access the OData service is an authenticated request. And in a build script, you don't want to have to be fiddling around with creating JOT tokens and all kinds of nonsense like that. You just say, just give me the XML. Okay, so let's just make a local copy. In your cargo TOML file, there are a few basic dependencies that are needed. So at build time, you're going to need to depend on the OData, SAP OData crate with the parser feature switched on. I was thinking about this yesterday, I could actually optimize this, but the source code generated by this parser, it generates source code that has a dependency on other structures in the same crate, which is why you see the same crate at build time and at runtime. Now, yes, I could take those common dependencies and split them out into a different crate, but that would be a breaking change, so I'm not going to do that at the moment. But, so this dependency here is because the source code generated here actually has a another dependency. And this atom feed crate is the crate that actually uses the generated code and then interacts with your back-end SAP system. You're going to need SERDI and QuickXML. And depending on which EDM properties are encountered in the metadata, you might need these other crates here. But it depends what data you're pulling in. One point about QuickXML, something that I tripped over when I was developing this is, and I hope this only applies to the demo OData services that I was developing against, some of the XML that comes out of the demo system is not actually valid XML. It's got some weird, unescaped characters that cause QuickXML to throw its toys out of the pram. And I was pulling in this XML and I was parsing it through QuickXML and I think, hang on a minute, this is all falling to pieces. And it took me a while to find it, but there were some weird quoted strings that had other characters inside the quoted string that should have been escaped. So one of the things I have had to write was a little XML sanitizer. So before you pass the XML into QuickXML, I run it through this sanitizer that looks for these known naughty bits and cleans them up, and then you pass it into QuickXML. So that's what your build script looks like. It's pretty straightforward. You call the genSource function. There is the name of the file, which is this one. You don't need the XML extension. That is the name of the schema inside the metadata XML. The reason you have to name the schema is because according to the OData standard, an XML service could be delivered with multiple schemas. Now, I've never seen an SAP system do that, but if you look in the hierarchy of the XML for the metadata, you get the top level EDM data description, then you get schema, then you get contents, and potentially there could be a second schema. So you have to name the schema, and typically this will always be the same as the name of the service, just in uppercase. So that's it. That's all you need to do for your build script. And once that build script has run, if you look in your target debug build folder, so there's a project name, Rust Global Demo. That project name is then used down here with a build hash, and then in out, there are the two modules that are generated by the build script. Now, simply for time, I'm not going to dive into these because there's a whole boatload of detail that really isn't important, because the focus of my talk here is to show you how business functionality can be implemented and not to lift the lid and actually see how the nuts and bolts work. And that's really largely because of time. So once you've got that source code generated, you can then start consuming that in your business application. So there's this little function that I wrote to sanitize the XML. I wrote a little convenience macro that pulls in the generated source code, and then you just bring it into scope as you would with any other Rust module. Now, if you want to see a demo of this, if you pull out this repo from my GitHub account, this will run a Rust module or a Rust application that communicates with this GW sample basic. But before this is going to work, you must have your own user ID and password for that SAP ES5 system. And then, as you would with any other credentials, you put that into a .env file, which this program picks up at runtime, and that is used to authenticate against the SAP server. Now, I have made absolutely no attempt to make the data look nice in your browser. It just says, here's a drop-down list of all the entity sets, and you select one of them, and it gives you the Rust format output of all the Rust structs. But the point is that all the XML data that comes out of the SAP system has been transferred by SERDI doing its magic into a hierarchy of Rust structs, and that is now available for you to write your business application. And those Rust structs are just dumped straight to the browser screen. So making it look pretty was not my priority. Making it work was my priority. So, yeah, that's basically a broad overview. As an aside, was there like 1 or 2 people who've actually used an SAP system? One?
As a user, rather.
Okay.
Far downstream of this work.
Okay. So SAP has a cloud platform called the SAP Business Technology Platform, or BTP. That is based entirely on Cloud Foundry. So when I started developing this software, I thought, oh, I'm going to need to deploy my Rust application to Cloud Foundry. So I went onto Cloud Foundry's website and I was hunting around for a build pack that would allow me to deploy an application written in that language to Cloud Foundry. Oh, bother, there isn't one. It seems, I might be wrong, but it would appear that when I started this in 2023, nobody had ever thought that you'd need to deploy a Rust program to Cloud Foundry. You know, there's all the normal Java, Node.js, TypeScript, Python, all of those languages had a build pack, but there was none for Rust. So I think, oh great, I've got to go sit down and write one. That was an education. But a build pack is really just a collection of shell scripts. That's all it is, really. So if you are ever in a position where you want to deploy a Rust application to a Cloud Foundry cloud system, as you would if you're working in an SAP environment, then I've written the build pack to do that. So that's the end of my talk. We've got time for a few questions.